I'm thrilled to be here. There's a full room of people, and it's my first time in India, and so I enjoyed yesterday the whole day of tours, and now we are here this morning, so many people. I'm not sure, is this two? I'm not sure. Okay, it's just a sound for me. So, okay, so what do we do? Amplifying human abilities. I think this is sort of a big goal, and for me the question is, are we at the dawn of a new age? Is there some fundamental change to come? Are the technologies we're going to see over the next few years really fundamentally change what we can do as humans and who we are as humans? But before I go into sort of the details, I have a task for you. So I think Philippe started with this, you have to do some work. And I'll start with something much easier. So it's about being happy. And I think this is one of the global challenges. I think obviously there are many other challenges, and I think we had yesterday's tours around Mumbai, a huge city. But I think making people happy seems to be one of the really big challenges. And I think even if you look into more detail, I've recently been speaking on a workshop on mental health. I think being happy is one of the very fundamental things. So what we do now, we have a design exercise. And the design exercise I have for you, and I give you 90 seconds, and you don't do it by yourself because it's a conference. You're supposed to meet other people. So I think if you have a group of 3, like there in the front, or a group of 2, stick your heads together. You have 90 seconds, and really think about, can we create a technology that makes us happy? And literally, it's not like, oh, designing something nice that makes you happy. Really, can we build a technology that physically makes us happy? Okay, and I think Philippe had some ideas. I think I have done some EMG stuff, and he left that out in the introduction. Yesterday he said he's going to say it, so it's good that he didn't. So we did some work on physically stimulating people. I will talk a little bit more about that. And that really sort of keep your mind open. And I have a countdown for 90 seconds. Talk to the person next to you. Design a system that makes you happy. Okay. Time is up. So you have your 90 seconds. You designed the system to make you happy. And I think next, in 2 years at Interact, there may be a track on systems that make us happy. So just sort out the authorship between the people who were sitting next to you. So I also had my 60 seconds, 90 seconds to think about. And I talk about a system that I think is a very interesting use case in a way why it's not that easy to really create systems, oh, thank you, to really create systems that make people happy, and that basically the task I just gave you may be sort of an impossible task, even if companies like Facebook, we know they actively try to do that. And I think it's something, it's from an ethical perspective, but also from a technical perspective, it's something that's not really. I'll give you some examples, what we recently discussed. So this is a device one of my PhD student, Yomna, built. It's for a project I'll show you later. What it does, it has a number of cameras, like a thermal camera, it has a RGB camera, it has a depth cam, and it has video screens inside, so you can do video see-through augmented reality. And I think the first time we thought about this, how to make this happiness device is, oh, you just take people's heads, you recognize them, and you replace them by cats. That keeps you smiling probably for the first day. It probably wears off, and I think this is one of those problems with happiness. I think then we can go a bit more advanced. We have physiological sensing in there. We can sense emotions, we can sense happiness either by looking at your face, looking at your facial muscles. So we could start learning what you like to see, what environment you are in, and we just provide it to you. And interestingly, we could... It's better if you use these ones. Okay, so... Sorry. Okay, no worries, I can take this on. Yeah. Okay. Yeah. Okay, so can you hear me? Does this work? Okay, perfect. So if I walk off, give me a sign. Because I'm a bit of a walking person. So we can build those devices. Technically, we can build something like this, but it's not going to make us happy. I think that's this is this dilemma we are in there. I think creating a technology that makes us always happy is sort of one of those dilemmas we are in there. And I think we see a lot of companies trying it, and I'm pretty sure they're going to fail. This was sort of to get you a little bit motivated about sort of this change of age we are in. And also, I hope you met a nice person sitting next to you. So this is sort of the outline. I'm not going into detail. I'm going into the first question. There are probably a number of people playing chess. You have heard of that board game, which once humans dominated. And I think 96, 97, the first computers won, and Kasparov apparently got really upset and figured out that's not really fair. 2006, I think 10 years later, everybody knew computers play chess better than humans do. Nowadays, 2015, what is the most interesting chess you can look at? What's the most interesting chess? So I haven't seen very little chess tournaments, computer against computer. But what is really interesting, what we see is, it's called freestyle chess. It's a set of people using computing power playing another set of people using computer power. And some of those people who played say that's a much sort of higher class of playing chess than what we have seen before. So basically, people harness technology to play against other people harnessing technology. And I think this is sort of, for me, a symbol we can use. It's basically, we will have technologies that are better in certain tasks than we are, especially if their tasks are well defined. But that should not keep us from pushing on, because what happens if you use the technology and you put it together with human creativity, you get to a whole new level. And I think it's not just for chess. There is a website, and I have a daughter, you saw her when we switched. She's 16, and in Germany that's a time when you really think hard what you want to do. And so there are websites where you basically, you have an idea what you want to do, and you can look up how easy this is to automate. So basically take your job, and I think you can take the university professor, and luckily there are multiple websites, so you choose the website where you have the least automation. So I think for a professor you get something like, 90% automation, really easy to automate. You just record him and replay him. And then you have other sites where, it's all about motivation and you can't automate it. But I think what we know is a lot of the jobs we know at that moment, they will be automated at least to a large deal. I think for the US, there are some studies where they say one of the most common profession is truck driver. And driving in the US is very different from India, I figured out yesterday. So there is a big belief that sort of a lot of the truck driving can be automated. I think if you probably would put a car, an autonomous car with the current algorithms in Mumbai, you can pick it up 2 years later at the place where you left it. It probably will not move because I think with the current algorithms, I think it's not fit for this. And I think this week there is the Automotive UI conference in Germany, and I think we had some discussion on this issue, sort of on the global issue. So I think what is interesting, there are a lot of jobs that will be automated. And the question is, what does this make us as humans? What does it do to us humans? And I think there are quite some serious scientists who believe that we have the chance to destroy our human society with artificial intelligence. And I wholly disagree. I think this is this problem with chess, what we had at the beginning. So obviously, sort of, it's not the end of chess. I think some people say it's the beginning of a new playing if you get computer assisted. And I think most of you are probably not really upset that they're slower than a car. I think we've gotten over that. So I think we use the car to get faster to another place. And I think this is something we have to really understand, that this is happening at the moment with computing. And that's where our profession, human-computer interaction, becomes center stage. It's not the algorithm anymore. It's really what can we do with technology that's really smart? How can we use that in order to make us smarter? And that brings me to that point, amplifying our perception, amplifying our mind. Now the question is very often about intelligence. And if you look back in history, there has been about 200 years ago in Europe, 300 years ago, it's called an industrial revolution. And it was a time when muscle lost its value. So if you go 500 years back, if you were really strong, you could work in a quarry, you made a lot of money. Once big machines came, having muscle lost its value. And I think we may be at that point that a certain type of intelligence is going to lose its value. And that is the question, what type of intelligence, artificial intelligence, can replace? And I think obviously people have been talking about other forms or more complex forms of intelligence. And I think there have been studies that your success in life is not the raw intelligence like the score of your school. It has a lot with social abilities, social intelligence, emotional intelligence. And there's one other interesting point. I think gyms, like going and doing sports, is still something a lot of people do. Even so, your muscle is in the workplace not really sort of the top priority. For mating, for finding partners, that seems to be still of value. And perhaps the same is with intelligence, with the raw intelligence. Perhaps sort of being intelligent will you at least, if it doesn't put you at a potential beneficial place in the workplace, with mating, with finding other people who want to be with you, that may be still an advantage. So keep it up, the intelligence. There's one other thing when we go back to this question. So if you look back, sort of the strong people lost out very quickly over 50 years when power machines came. Now the question is, and I was 2 years back in Cambridge, and we looked at where do our best graduates of computer science go? What are the aspirations they have? And what you find in, especially in Europe, a lot of the best people, they go into finance. Because there's a lot of money to be made. And the interesting point comes now. One of the predictions is that one of the jobs that's most easily automated, which is now very strongly linked to intelligence, are financial brokerage. So I think we may be at that point that the strongest, like the biggest guys that lost their jobs 300 years ago because they were muscular but didn't have much else, that the people who go into finance, because that's sort of where you make the most money, where you need the most intelligent people at the moment, may be replaced in a very short time. So I think that's an interesting question. And I think when we now design systems, it's really the question, how can we harness, amplify the intelligence that's relevant. It's not like intelligent as a concept is very complex. So it's what is the relevant parts? That's why I'm usually not separating between perception and cognition. I'm using sort of the mind as a term because I think we need both. And so what are we going to build in that case? Human-machine systems that outperform humans as well as machines. I think this is sort of the core takeaway. I think I will have a lot more slides, but it's getting darker and so people are getting tired. So this is sort of the takeaway. We build systems. If you build a system and it doesn't outperform a computing system, it's useless. Leave the human out of the loop. If the system is automated better than with the human, leave the human out of the loop. And I think we have seen a lot of those systems. And if the technology is not outperforming a human, leave the technology out. I think we are better off if we don't have to deal with the technology if it doesn't help us. But I think the sweet spot also for many, many places in work, in life, is this where we have systems that are better than humans or machines alone. And herefore, human-computer interaction is one of the key disciplines. Because that's the discipline that knows how to make those systems. And we know it's not trivial. I showed you with this very simple example in the 90 seconds at the beginning. You probably came up with a lot of ideas, but with your professional knowledge, you knew it's not going to work. And I think a lot of other people are coming from other fields are much more naive about sort of building a system that makes you happy. And I think we know that a lot of things in this interplay between human and machine are really hard to do. And I think it may bring a renaissance to a term we haven't used much. It's this intuitive cooperation between humans as the key challenge. I think we haven't used the word intuitive because it's a very difficult word, but I think that's something we are probably looking for in the future. And I think machine learning at the moment hyped, I read yesterday an article, it's sort of those companies are at the moment at the top list of the VCs. That alone doesn't really help. I think you need to put it into the context of human use, either as a consumer or as a contributor. And I think this is sort of on the side of the processing. And I think I have another side just as important as our mind is the perception. And I think many of you have seen such pictures, but you have never seen that in real life because your eye is much too slow. And I think this is also an interesting development. We have now sensing technologies that can see, feel much more than we can do. And obviously, to take such a picture, I'm not sure if you have tried something like this, it's a real effort because you take the picture, you look at it, you have to get the lighting right. And the question is, medium term, can we create systems that just allows us to see such things if we want? And I don't do the design exercise here because I have it later as a solution. So, how can we amplify our mind? How can we amplify the senses? How can we use tools to improve our perception, our cognition? How can we extend our memory? That's the basic function of our cognitive system. And then comes the very big question. I think we as a community haven't answered this. Can we quantify how much better you get if you have technology? And I think that's something, if you look through the proceedings of Interact, the proceedings of Kai, that's something that's missing. We don't know how much impact technology use has on what we can do. Very often we say, oh, it's 3% faster to do text input. For this task, it's 10%, but we don't know. So I think one of those questions, take a university entrance exam, take 100 students, you put in this lecture theater, you let them write the test, take another lecture theater, take another 100 students, give them an iPad and let them write the test. What will be the outcome? How much cleverer will the ones with the iPad appear? Will they appear cleverer? We don't know, and I think this is something which I find fundamentally wrong, that we haven't measured those things, that we don't really know what we gain by using technology on a raw scale. So, this is sort of the motivation. There is technology, and I think we want to get the technologies together. Now comes the question, how do we get those things into our life? I showed you earlier wearable technologies. That may be one way, but it's a really big question. And I think the question is very simple. How do we get it into people's lives? Through things that surround us. So, what does surround us? How many things do you own? Philippe, how many things do you own?
256.
256. I think he's underclaiming. That's probably what he travels with. So there's an interesting question, and I think there are a lot of answers to it, and I think you can just go mentally through the things you just used while traveling here. And the question whether you own is important or not, I think that's another question, but it's a lot of things. There are websites, minimalist websites, so somebody claims they have 72, but if you read into the details, they have a few more, they sort of group things together. Then there's another website that somebody has collected 288, so that's very close to with what you travel. So there's furniture, decorations. But I think this is sort of much too low. So what we usually find, there is sort of no clear number, but some people claim it's in the hundred thousands of objects you have at home. In the US, I think it's different around the world. But what we have is, I think it's always 3 digits. It's very high. And I think one question is what you own, then people say, oh, you own a lot you don't use. But also if you just look what people touch during the day. There's an artist, Paula Zuccotti, she takes pictures of what people touch over the day. And you can guess what that person is. A musician. What else can you see from that? A woman. So I think you get a lot of ideas, but I think this is only what a person touches during one day. And interestingly, it's a lot of wearable technology, but also a lot of technology in the environment. And I'll give you another one for guessing, and then we are sort of moving on. That's a harder one to guess, but I quite like it. Mother or father? No. No, a female doctor for kids. But so, it has to be sort of a bit more tricky sometimes in questions. There's also scientific work on how many things we touch. Alberto Frigo has recorded, I think, all the things he touched since 2003. It was published as a work in progress in CHI 2016. So there are a lot of objects we interact with. And I think once we think about how to make people smarter, we have to really think about all these objects. And so, just a sideline, why get people excited about the Internet of Things? This is because there are so many objects out there. This is really, at the moment, you have 10 to 50 computers in your environment. And I think this is sort of scaling up a few number of times. And I think this is sort of why everybody is really interested in that topic. And I think also we as sort of professional in human-computer interaction, I think it has been underrepresented. I think we wrote 2010, we wrote a paper interacting with the Internet of Things. I think this is a topic we have not really looked in, and I tell you later why, if we leave that to the other professionals who have no ideas of interaction, we end up in a world that's not nice. But this is sort of another one for later. So, what surrounds us is tools and media. Basically, we can get other categories, but I find those categories from a technical perspective quite interesting. And I think tools are something really interesting. Tools are, it's a wide concept, and it separates us from animals. Other animals use tools, some animals even make tools. But in the end, I think if you look at the quality of tools, the ingenuity in tools, it's humans who have basically linked their tool-making skill to their evolutionary process. And I think if we compare a shovel to a big digger, then we have seen how quick it went over the last 200 to 300 years. And this was sort of in order to amplify our physical abilities. And now imagine Google is the shovel for the mind. What is the digger for the mind going to look like? And I would expect we have probably an equally fast development. That's why I had this argument, we probably are at the beginning of a new age. And I think computing at the moment is still at its very beginning. And I think we have seen how quickly the internet changed things, and I think with amplifying our abilities, we may see a similarly quick uptake. At the same time, media is changing, and it has changed over the last 5,000 years. And what we see is it speeded up recording and presentation and delivery. And I think we are at this moment where even the term of media becomes quite interesting, because as we can print products, it becomes sort of this a thing or data or media, it really blurs. And also the production is changing. I think at this moment we're still in a life where we deliberately record things. I would expect within the next 10 years we move to a different mode where everything is recorded and we just choose what we want to look at. And that's extremely, it's an extreme change in what we have. So I think I have here put YouTube pictures on. I think there is nearly nothing on operational knowledge you don't find on YouTube, whether painting your toenails, changing a hard drive, you will find a lot of, and this is, people did this deliberately. Now imagine everybody's recording what they operationally do all the time, and we can have access to it. So this is just sort of the question about access to knowledge, understanding knowledge, dealing with knowledge becomes much more important than having the knowledge. And I think there's always this tricky question, is it knowledge if you have a video or is it just information? I think this is the question of the interface. And tools and media become enablers. And I think if we look at things like cars, buildings, they would not be possible without tools and also with computational tools. So I think we are already in the middle of a world where the tools we have are definitely changing what we can do, how we can do things. And the idea of media being ubiquitous is one of the major accelerators in my view. And there was another change in society, and that's already, for most societies, many years back, many thousand years back, it's this question of, do we have an oral society or do we have a society that writes things down? And what we see is those societies that have started to write things down outperformed the societies that were oral. And there is a price for that, and I think it's interesting. Socrates told his students, it makes you stupid if you write things down. And I think we have the same discussion at the moment. If you use technology, it makes you stupid. It makes you different. I think there is no question. It changes your brain if you use technology. But in the same way, if you take a child that can read and a child that can't read, and you put them in a brain scanner, they have different brains. It's obviously all the things we do will change our brain. And so this question of changing from this society that deliberately records to a society that has all the knowledge at its fingertips is going to be as fundamental as the change from oral societies to written societies. And I think the question about opting out comes here, and I think it's a really difficult one, and I guess it's very similar to the writing one. If you nowadays opt out of writing, you're probably not going to make it to university. So how do we aid cognition? How have we built tools? And I think we have cognitive and perceptual tools. It's not something new. That's the desk of my daughter, sort of a calculator, a watch, writing. We have a tradition of cognitive tools. It's just that we are at this moment that we had a simple, small set of cognitive tools, and at the moment, this is just sort of really widening up. The potential for cognitive tools is exploding in a way. Similarly, we had traditional perception aids, like sort of hearing aids, like navigation equipment. And I think here too, we see technologies at this point that this becomes widespread use. And here we still have this model, like the glasses, like the navigation, you use it when you need it. It's not becoming part of you. Interestingly, hearing aids are much more in the idea of amplifying your abilities. And now let's put this vision into context. So obviously we are not the first one to think about sort of amplifying the human mind. There has been a lot of work, and you could really look back at the term of augmentation. Whenever Bush, as we may think, in 1945, I think if you haven't read it, that's sort of a must read. We do it with students. It's really, interestingly, it's pre-internet, but it gives you so many ideas of how this amplification of bringing information to people works. Lick Leader's idea of the man-computer symbiosis in 1960. Douglas Engelbart, don't read the mouse stuff, look at augmenting the human intellect. It's really this question on the next step, and I think Mark Weiser pushed this further to everything that surrounds us, putting technology in the things that surround us. DARPA has looked at augmenting cognition with a very clear view that if you have it and the others don't, you have a clear advantage. So what is the motivation for this? On a theoretical basis, there is a lot of work on extended mind, active externalization from cognitive science, from psychology. So it's well understood, it's just not implemented. Distributed cognition, similar, it's well understood, and we're not really harnessing that with the technologies we have. Collaborative knowledge, group cognition, uses space as sort of means for thinking. I think we do this in the real world, but in computing, if we look at be it sort of a tablet PC, be it a phone, we don't use much of space. It's very similar to what we had in the 90s. So I think there's a lot of potential where we can really enhance it. And the technology push we see, I already said, we have sensing systems that are superior to our senses. We have advances in AI and processing, and we have devices for presentation like sort of augmented reality systems. So I think that the time is right that this happens. And now, how do we build those systems? And I like to use these two metaphors. And I think what we see at the moment, a lot of people build binoculars. Another app to do X, another app to do Y. And basically, each time you want to do that, you look for your phone, you take it out, you do it, you put it back. But what we really want is something where we go beyond the binoculars from a conceptual sign. So I think some of you are wearing glasses, and I think you were not aware till this moment during the lecture that you were wearing glasses. Only when I bring up the term glasses, you become aware that you wear them. And I think this is something what I talked earlier about, intuitive interaction, getting to a point that we can design technologies in a way that they are becoming a part of us. And I think glasses manage this very well. And I think binoculars don't. And so I think the other lesson learned is sort of try designing glasses rather than binoculars. Now I give you some idea of a project we have just started last year, where we really want to experimentally try those things. This is sort of, again, still in the vision. I have then later a few much more down-to-earth things what we tried. So the vision, what we have, is really creating digital technologies that amplify human perception. And it has two parts. The idea is to create amplified artificial senses. The other one is to look at, can we create artificial reflexes? I'm not going into the second one because that would need sort of a bit more background. But the first one is, can we create senses that are natural and intuitive to use, that are superior to what we have? And I think I show you one of the things we have been building, playing with. So the idea is, we need means for controlling such devices. And obviously they are implicitly and explicit, so we have a lot of sensing in our case, signals from the brain, signals from our muscles, our gaze behavior. And then we have a number of cameras, because in that way we look at visual perception. So imagine you have a camera, you have a high-speed camera, you have a low-light camera, you have a camera that looks at heat signals and so on, and you get them into the system. And basically what those two things are, sensors are effectively just values coming in, and displays are typically two-dimensional pictures or three-dimensional pictures coming in. And then we have models that predict what you want, what you do, what you look at, and we have models for how to display them. That's in the end just data. And then imagine you can switch between the thermal view, between the depth view, between the RGB view, and you see it, it's the output in the end is also just a picture. And what we really do is we're interested in the algorithms that are in the middle. So basically, how do we create algorithms that allow us to use our natural interaction with such a device, and we imagine it be glasses or something like this. How do we create such a thing that we can naturally use it? And I'll give you an example how I envision that this technology works. And we are not saying that this is a good technology or a bad technology. It's really something where we say we have to build it in order to understand what it does to us. Now imagine I have glasses with this function. I look up there, I cannot read what's on the sign, I concentrate, perhaps I squint my eyes, that's recognized, I zoom in, I can read it, and once I have read it, it's zooming out because it's automatically recognized I have finished reading. Or I look over there, I see perhaps some bird flying in, I think I can't look out, I see a bird, I concentrate on it, and by just concentrate, I can slow it down. And once I look back here, I'm back in reality. And technically, we are at that point, what I said, we can build those things, but we are not sure what they do to us. And so this is sort of one of the big things I'm at the moment really sort of excited to try out, because we really think this is probably changing a way we perceive our environment, we work with our environment. And I think this is sort of, as I said, this is a device we have built 2015. It has gaze tracker, EMG, EEG inside. The idea is that by 2020, this looks a bit smaller, that we can build it. By 2030, it's just integrated in my classes, and I'm probably not looking that young anymore in 2030. I'm not looking that young at the moment. Now, a lot of people shout, information overload. But I would argue it's something very different. If I take off my glasses, the world looks pretty much like this. And I think some people may recall from last Interact where this is, even if it's blurry. If I put on my glasses, it looks like this. And I would not argue that this creates an information overload. It makes me seeing the world more clearly. And if you haven't seen this when you were at the last Interact, you have to visit Tom again. So it's taken at last Interact. So with this, I will spend the next 10 to 15 minutes, and then we are done, with a few examples where we tried over the last 5-6 years what this notion of amplifying, of augmenting the human mind could look like. The first project comes out of the accessibility domain, helping people with cognitive impairment to be successful in the workplace. So it was a 4-year project, and what we looked at is assembly tasks. So you see there, the person is assembling a car starter. This is not highly complex, but I usually can't do it. And there are about 50 variants of car starters. And so the question is, how can a person with cognitive deficiencies do that? And then, obviously, you could train them, you could provide manuals. But what we looked at is, can we build a system that learns from the people who know how to do it, like the skilled workers, and transfers it to people who can't? And we build a system. We like to build systems. I think prototyping is one of the things we do. It has a lot of cameras, it has projection, and I have one example of the replay where we did a trial. So this is a person, he is building a fairly complex structure. For test reasons, we used Lego because they are worldwide available, so you can reproduce the things. Obviously, we did this in a company with real things. But what we see there is, if you always see just the next step, so the person sees what to grasp and where to put it, it's very, very easy. The complexity doesn't increase. And the interesting part for us was also that we can automatically create these instruction sets without having somebody to program them. Because once you have somebody to program them, it doesn't scale. And I think, so I go quickly over the study design. This was sort of, we looked at different complexities, and I just come to the result, because I think that was the first time we realized that there is something with a really high potential. So what you see is the green line is for the in situ projection. That's what you just saw, where you have this. The yellow line is where you have a traditional menu or where you have video instructions. It gives roughly the same line for both. And what you see is the time required per placing a brick, and that could be a screw, could be something else. If you have the in situ projection, it's constant, it's not changing. If you have traditional ones, it goes up. And similarly, the error rate per brick is keeping constant, because I think the complexity is not increasing. If you give people instruction, it goes up. So this was for me, once I saw this data, this was, it seems obvious, but it's one of those very strong points where we say, from this perspective, creating assistive tools that help what we can do can really change the playing field. And what we had tried this with workers at a big car company in Germany who know the stuff. They didn't like the system because they could do it without it. We tried it with a sheltered work organization, also in Germany, building the same stuff up. They have really sort of very low, cognitively low-able people. And they were really extremely happy. They hugged the researchers who brought the system. So like they were really happy to use it because it put them nearly on the same scale as the other workers. And I think this is something quite interesting. So there is a chance to create technology that merges sort of the digital divide. But this was the only example where we saw this. In all other examples, we rather saw something very different, where basically that's why the term amplifying comes in. We usually saw that it amplifies people's ability. So if you have a lot of ability and you use the technology, you get even more. And with this, I come to the next example. This is augmenting the human memory. And augmenting the human memory, we looked at if we always record what we do and we give people the playback to learn what they have done, how does it change their life? So basically, we use different types of cameras, cameras wearable, worn by the people, cameras in the environment, and we looked at what happens if we record. And we did a number of trials where we did large recording sets, large data sets, and so the typical setup was you wear the camera's in the building, and in the evening you get a 3-minute replay of your day. And by this, you remember things you see again in the evening. Now we come back to the happiness device. How can we build with this a happiness device? So I'll just show you again the technology we used. Don't go into the details of the experiment. It's in a paper. So how can we build a happiness device? So very simple. We record every day about 1,000 pictures. In the evening, we show you 3 minutes the pictures where you see happy people. What sort of impression do you take away for that day? It's a good day. Now, if I'm sort of a bad person, how would I design the system the other way around? I pick out the scenes where you were in quarrels, where you sort of acted stupidly, where you did mistakes. I think I could make your life quite miserable showing this to you every 3 minutes in the evening. And I think this shows already very simple technology, lifelogging. A lot of people have done it. By just the selection process, we have a really huge impact on people. And at the moment, the selection is very often just sort of random. So if you upload the pictures to Flickr, it will typically pick for each album a random picture as sort of the thing. If you put it into a Windows folder, some of the pictures will be picked up. So the pictures you see more often are much more dominant in your memory than the other ones. And by this, you give external people access to changing what you think, how you think. And I think at the moment this is very random, but seeing what Facebook does to our feed, it's very clear. If those technologies come on, you probably get get the non-paid version, which gives you sort of a random selection, and you could pay for your lifelogging device, and it gives you happiness by just choosing the happy pictures. And I think this is sort of a problem we saw in that project, and I think, let's jump over this. These risks of memory augmentations, we wrote about it. I think that's something, was another point that made me aware. We have to try those things out. We cannot theoretically think them through. We have to try them out to really see many of those things. Once you see them, they become really obvious. And the final project, only short, to bring you back to that device which I used at the beginning for your happiness exercise. It comes out of a project. It's the German word Feuerwehr is firefighter, and it's wrongly spelled because it's an acronym. And we looked into, can we extend the senses of firefighters in a way? And what they usually have at the moment, they have a device which they can hold in their hand. And we recreated that device with the additional functionality of depth sensing. And we created a helmet-based version. That's the first version. You don't want to go into a fire container with this one. By now we have further versions. And now the question is, what is the difference between those things? And it brings back this metaphor of binocular versus glasses. And obviously we did sort of these, we put them into training scenarios with those things, either basically having it on their face or having it in their hand. And the device we have built and over several iterations, and I think the current device looks more like this, what you saw earlier. You can switch between a normal view and a thermal view by just concentrating, using EEG and EMG. And we also look at gaze patterns. And so we have sort of some sensing inside. And I think at the moment we are still not sure what it does to people, how well it works, because obviously sort of these people work typically under stress. And if you give them new technology, even in training situations, if you go into a burning sort of container, it's still a stress situation. So it's an interesting question. Can we create technologies that really put us to this point where we can use it without realizing to use it? And with this, I'm already nearly at the conclusions. And I start my conclusion with something you have probably seen. If you haven't seen it, I always like it. The user interface is like a joke. If you have to explain it, it's not good. The problem is, I think as long as this is with user interfaces, you can start explaining. And I'll give you one example why this may not scale to the world we're heading for. I recently was in a hotel. I'm spending quite a bit of time in hotels, sort of traveling around the world. This was in Germany, and I was at reception, and I got a quick tutorial on how to use the door. And I figured, boy, I'm over 40, opening doors, one of the key skills I managed so far. Not so much. And this is sort of the Internet of Things problem I said earlier, and that's why I'm so focused on the things that surround us. So I got and basically it's a door, you have to press, basically it's an RFID door, you have to press the button. Once the green LED lights up, you have to put the RFID card in front of it. Don't do it before. And if you do it right, it flashes and the door opens. If you do it wrong, you have to wait till the red light comes on and you can press again. So quite interesting design, and I think first you think, how can you design something like this? But then if you step back 30 seconds, it's very clear why you design it. It's marketed as a lock, you never have to replace the battery. It's very clever from a hotel management perspective. They put a battery in there, and because you only activate the RFID reader once you press the button, the battery will last forever, and you can put it into a very small housing. It's cheap. So it's a very clear engineering decisions, and that's why I said earlier, don't let the engineers make the user interface decisions. Because that it's from and I presented that at a big engineering company, and they said, what's wrong with it? And it was really sort of, and I didn't really, I took 5 minutes to convince it's probably not a good idea. Just think at the resources you need at the staff. You have to tell every customer. And it was just, oh, but it's really a cool design. You never have to change the battery. You don't have to wire it up. It's really good. But I think now this is a door. Now imagine Weiser said 100 devices in a room, 1,000 devices in a room. Imagine you go to the hotel, you have a 3-hour tutorial on how to use our room, and then the night is over. That's sort of, usually for me, sort of this time. So you don't need to go to the hotel, really, because all you get is the tutorial. And I think this looks a bit like a joke, but this is real. And I have a few more examples. I have most of them have German instructions because I collected them in Germany. But the windows in our department come with a 1-page instruction how not to open them. So you can open them in one way, but there are a lot of ways of not to opening them. And I think this is sort of not scaling up. And I think if we want to really empower people, create this amplified sense, we have to be able to do it in a way that people don't need instructions. And I think it's not down to another smart device. It's really, it is our environment where this becomes really critical. And so, in summary, we do experimentally explore those things. Even so, we may not know if it's good technology or bad technology. And I really strongly argue for, you have to try it out, because just thinking about it is not going to cut it. And I think for me, one key thing is I'm really interested in how ubiquitous computing and media is changing what we can do with our minds. And one other point, also as sort of, from my experience, a lot of the things we learned by going out, I showed you the example of the car starter, of the firefighters, to really go out, work with real people, because sort of it's very, very, very different. And I think I made this point that we are missing the way of measuring how we gain things. I think we as a community should start to do that. If we don't do that, if we sort of just measure mini things, really small things, we are not going to change the world. I think we really have to show what it does if you have a good interface. And in summary again, create technologies that allow people to live happy lives. I think it's sort of obvious that we can't change happiness with a device in the way I sort of hinted at the beginning. And with this I come back to the very beginning. Are we at the dawn of a new age? And I think yes, we will amplify our minds and senses through technologies in unprecedented ways. And it's probably more complicated than many people from a technological perspective see this. And I have a few things on further reading. I'm really sort of very strongly advocating prototyping, and I was quite frustrated with some of the conference in our field recently, and I wrote up something, a plea for making prototypes. Don't really just think about, I think it's really good to do paper prototypes, but don't get stuck there. Really try it out with people. If you don't do it, you're not getting there. So that's sort of, it's more like sort of a mission I'm on. That's why I put it into, shamelessly into my own column. There are a few more, I think, on physiological interface. I put this in case you would have said something, and there's more further reading. And now I'm very happy to have questions.
Thank you very much. I'm just doing a test. Yes, the microphone is working. So if you want to ask questions, please just come here and ask a question to Albrecht. Okay. Meanwhile, I will start with the question so you can be starting moving, and you will have started already. So I just have a question, which is kind of a surprise for me. So you were talking about perception and cognition, putting that into one word, which was mind. But you never talk about motor, and if you look at some conference in HCI, there are a lot of paper on Fitz's law. So how would you relate motoric aspect and amplification on motoric aspects?
I think on the motor aspects, we are very far, and I think we are probably not the best community to do that. I think we did some stuff with electrostimulation, and what I learned, I think, especially in Europe after the big wars, people already tried that because they were sort of there was a need. And I think a lot of stuff we see in the Kai community is sort of 60s work of the communities that have been out there, like the medical community. So I figured I'd stay away and go to the cognitive side. And perhaps I'm the person who would most benefit from it. So I think that's another point.
Okay. Thank you. Question?
Sorry. Hi, my name is Kove Bazargan from Iran. Thank you very much for your inspiring talk. I have a brief question. So there is a say a quote by Albert Einstein. He says, if you want to live happy life, tie it to goal, to meaning, not to people and things. What is your reaction? That's first.
So I didn't get the second half. Can you just read it?
So the quote is from Albert Einstein. It's, if you want to live a happy life, tie it to meaning and goals, not to people and things. What is your reaction? And the second one is that I'm coming from Iran. Okay, it's a country in Asia. The ACM Code of Conduct talks about being very respectful of the human being. So in my country, they're using a lot of artificial intelligence and so many things that you showed. But if you do not respect the code of conduct, which says that you have to respect the human being and being transparent, it can become very totalitarian. So I'd like to have your reaction about what we presented. Thank you.
Okay, thank you. I think the first was on the Albert Einstein quote. And I think it's about goals, which I'm really interested in. And I think in the end, they even link very well together, those two questions. I think things don't make us happy, we know that. But I think what I wanted to put forward with the minimalist view, even if you think you don't have things, they will surround you and will impact your life. And I think we have seen this sort of, your living circumstance will impact your life. And I think in former times, we didn't have much chance in changing that. So if you lived in a cave, if you lived in the forest, basically the environment was very much given. And I think by accumulating things, we are not getting happy. I think that's very well known, that's very well researched. But now we are in a world where we can create a changing environment. And I think if we don't respect the human, that where it comes to the second one, we can really try to create things that make us happy. And I think Facebook apparently chooses things that create more likes for them, because that makes more business, keeps you longer on the site. At the same time, those are things that are apparently the positive things. And I think there is also, we had 2 weeks ago a workshop on mental health and technology, and it's very simple. You cannot be 100% of the time happy, because happiness would be meaningless. So basically people who are healthy, they have sort of a fluctuation. And I think this is sort of respecting what we are as humans. And I think that evolution is really slow. I think that's another point. I think with the technology, we think we can change. Evolution is really slow. I'm very sort of confident on that side. It's not changing us quickly. But on the other hand, the change of our mind is very quick. So learning to read changes your mind. Reading one book can change your mind. And I think this is sort of something where I think we have to be very careful how to design the technologies. And I'm not saying that this is the good technology, but I say if we don't try it out, and if we leave it to commercial enterprises to try it out, we are getting technologies that get more engagement. And I think we have seen this with Google Glass, sort of increasing your time seeing AdWords is probably not just the only thing we should design for. Thank you.
Thank you. Can you tell your name and affiliation, please?
My name is Fang Chen from Australia. Thank you for a very interesting talk. I feel echo a lot one of your early slides talking about human-machine interaction, machine learning, all those changing world. So we see that in past 5-10 years, a lot of data coming from IoT you're talking about. So machine learning side progressed really well. On human behavior or human interaction side, most of researchers has been focusing on some experiment. So design variables, few variables with a group of participants, maybe 20, maybe up to 100. So very limited snapshot on very complex human life. And then if we draw some conclusion out of those features defined out of the small experiment, so we lead people, a particular portfolio of people to a right way, but a lot of others probably not. So considering the cultural history, education, different profile, even ambient, like a temperature, have a different perception toward people. How we can bridge this gap of creating more sophisticated even data collection in a real life scenario that you can utilizing a lot of advanced technology to bridge the gap.
So to me, I think the technology helps us to do that. And I think we have seen over the last 5 years, we also ran some workshops on basically large-scale data experimentation. So one of my colleagues in Stuttgart, he did a Fitts law experiment. I think Fitts law was the other question earlier. He did a Fitts law experiment with 100,000 users worldwide, by just creating a game that was downloaded by 100,000 people, and they played it, and the game was essentially a Fitts law task. And so I think this question, once we move towards always recording, once we move to networked systems, we will collect much more information, and so we can really create those large-scale studies. But I think the ethical implications of a study where you have a billion participants is just huge. I think we haven't really understood it from the ethical side. Technically, I'm very sure we can make a lot of those things. And I think if you look at companies like, there has been published how they improve YouTube. There was a Kai talk at some point. We know Facebook they are running those experiments on really large scales. It's only we as academics don't. And I think that's something we probably should move forward.
Comment, maybe that's one of the tasks that all of our participants should utilize in this kind of venue to think about whether we can work together.
Thank you.
Thank you.
We have time for 2 more questions, and then there will be the tea break.
Hi, good morning. I'm Rasagia. I'm a designer at Mapbox, one of the chairs for the conference. So this is slightly more for the whole population, that media tends to bring these dystopian scenarios out there for everyone to see, which are more from how does the impact of such technology happen from a larger perspective on a social level, on a system level? Do you have any examples that you feel that academicians are trying to incorporate, not just the immediate impact, but this sort of a higher level or larger duration impact of their research in the research papers that they're trying to develop? So not just the initial impact of the work, but what happens if suddenly everybody starts using this technology? And if yes, how are they going about this sort of a methodology?
So I think what we see is typically it's really hard to predict from a research perspective what's going to happen. And I think mobile technologies are one of those things, mobile phones. I think if you look back, it's the last 20 years and many of us have been working in that space. And I think it was probably really, it is sort of, if enough work is published, you can go back and find a paper that predicted what's going to happen. And I think 2000, there was not so much published, but nowadays there is enough published that we can predict it. But I think that's not how it works. So the question is, can we know from serious research what's going to happen? And I think there is my clear answer, no. I think we typically can say there are typical ways it can go, and we can perhaps assign probabilities or things like this, and if we scale up, we can get this better, but there are always different ways. There may be government influence, there may be sort of cultural influence, there may be sort of just trends that happen, and I think, so basically, I'm always worried if people tell me how it works. So I think if I don't see the options, and typically as a serious thing, if I'm doing something, I would really show these are the potential outcomes. So if I build those technologies, those are things that could happen, and I would guess with a higher probability that this is happening rather than that. I think that's a serious way of dealing it from an academic perspective. If we don't do that, if we say, oh, this is going to happen, we may be right, and if we write enough papers, let's say we have 5 options and we write 5 papers stating each, 10 years down we will get a 10-year impact award for one of them, and 4 are sort of wrong. So I think this is sort of a way that's why I think serious science looks at all sides, and that we really should be careful about the people who tell us the one truth how it's going, because I think they should just start a company and be rich.
Thank you.
So just a quick question. So you gave the example of by the way, Anirudh Joshi, IIT Bombay. You gave the example of glasses and binoculars, and sort of the interaction that we have with each of them is different in many ways. But one thing that is common between them is the notion of agency. Like, they don't take any agency, they're just tools. Whereas a lot of interactive systems do depend on the fact that computers take agency, they make decisions on your behalf. So how does that affect this amplification process, or is that the cause of all these tutorials? I mean, that's the reason.
So I think the agency is a very tricky one, because also the question is what qualifies a tool. Is, for example, imagine you have sunglasses that tune darker, and so that you can buy them. I think in here they would be clear out there. They're an autonomous system, very well designed. Would you call them a tool, or is it agency? So I think I would rather go for sort of sunglasses that tune, and I would still consider them as sort of in the direction I want to go. So I think autonomy is not sort of outside; it's inside. But I think, yeah, we recently wrote an article on sort of interacting with autonomous systems in the Interactions magazine, exactly looking at those things, because it gets really hard if people interfere with things that are automatically doing something. Okay. But I think we need to understand how to do that, and I think there is very little understanding of that. But in order to make this collaboration of intelligent systems and intelligent humans, we have to figure out how those things go together.
Okay, thank you.
Thank you.
Okay, I think, yeah, wow. So there is a last question before the tea break.
Hi, the question of the debate about whether technology upfronts a human got sorted out 60 years ago at Xerox PARC. I'm glad you mentioned Douglas Engelbart there, where in their frustration to find direct interactions, and they couldn't find it through artificial intelligence, they actually they had to fall back on the human ability for natural language and hermeneutics. And that eventually helped us develop direct interaction. So do you think that we've come a long way from there, recognizing that it's actually technology that repurposes humans rather than humans repurposing technology?
I think the repurposing issue is something that's quite central, and I think this is something, if somebody asks me, what makes us human in a way? And I think this is sort of this ability, you give us something, and we will solve what we want to do. So I think this sort of question of repurposing, that we give technology and that we do not underestimate human creativity and human ability in problem solving. I think this is sort of something, if you look around the world, and this is not an intellectual capability, I think you put people in a difficult situation where you have no previous answer, and most people will get out of it with the tools they have at hand. And I think we have seen this, so I think it's quite interesting to read survival books on that. I have been recently reading some, and that's more on the physical tools. So I think people will start to whatever they have. And I think what we see at the moment, people do this in the digital. And I think when we design for this, we should keep it open enough, because I think very often those things we design for may not be even the main use case. It may be just a small use case in the bigger picture. And I think so this technology adoption in very different ways is something we should definitely design for. Thank you.
Okay, thank you very much. So we are now ending this keynote presentation. So I would like you to join me and thank again Albrecht for this very interesting presentation. After hearing about deep learning and whatever, I think we have seen deep keynoting, and you can carry on having questions with Albrecht during the tea break that will be held outside, and we start again at 11.
Yeah.
And Aniruddha wants to make an announcement.
Yeah, just that the tea is both on the first and the ground floor, both floors, so whichever you can distribute yourselves equitably, that will be nice. Thank you. And we start.